Okay, we have here today another integral from the UNSW Integration Meet 2023 semifinal round 1, problem 1. We have the integral of 1 over sine cubed x cosine of the fifth x dx. Okay, now interesting thing here, we have sine and cosine, which typically we think work well together for a u substitution, but the trouble is they're both in the denominator. So really, if I pull this into the numerator, we actually have cosecant and secant, which is not really what we want. We'd like secant and tangent, or we'd like cosecant and cotangent. So I want to do something to manipulate this and kind of change it. And what I want to do is, I'm actually going to multiply the numerator and denominator by secant to the 8th x. And you'll see why. Kind of just adding these powers together, right? 5 and 3 is 8. So let's try this. And when I multiply this in, so we're just going to have secant to the 8th x in the numerator. So for my secant to the 8th x, I'm going to actually split this up. We're going to split this as secant to the 5th x and secant cubed x, because secant cubed x is just 1 over cosine cubed x. And of course, this is 1 over cosine to the 5th x. So let me just write this all out to make it really clear what's going on in the denominator. We're going to have sine cubed x, cosine to the 5th x, and then here with this split up, I'm going to have cosine cubed x, cosine to the 5th x. And this is what I want. I get to cancel off these cosines. But then what's going to happen is this here is actually tan cubed. So I end up with tan cubed in the denominator, and then this is going to be secant to the 8th x dx. And like I said in the beginning, I just wanted two functions that work well together, and now that we have tan and secant, I think we're in better shape here. So now I'm just going to split this up more to set up a u substitution. When I do my u substitution, I'm going to want my u to be tangent, and then we just know the derivative of tangent is going to be secant squared, so I'm going to split out a secant squared x just to set this up. Now if we do that, if we pull out a secant squared, we're going to have secant to the 6th left. So what I'm going to do is, instead of writing secant to the 6th here though, what I'm going to do is I'm going to use this identity that secant squared is the same thing as tan squared plus 1. And now just by cubing this, knowing that this here is secant squared cubed is the same thing as secant to the 6th, times secant squared is secant to the 8th. So I haven't changed it. This whole thing is going to still equal. And now at this point, I'm ready for my u substitution. So we'll just call my u equal to tan x, and then the derivative of this, the du, is going to be secant squared x dx. And we'll just go ahead with this substitution. So in the numerator, we're going to have, this is going to become u squared plus 1 cubed du, because this piece is our du, and then we're going to have just u cubed in the denominator. And next we can just take this thing, you could multiply it out, but I'm going to use Pascal's triangle to get the coefficients on this. And I can just write this as u to the 6th plus 3 u to the 4th plus 3 u squared plus 1. And then we're going to have our u cubed in the denominator. Okay, next I'm just going to take the u cubed and we'll divide it into each term. And that's going to give me, for the first term, we're going to have u cubed. Then we're going to have 3u. Then dividing here, this is going to give me 3 over u. And then we're going to have just this last one, 1 over u cubed, I'm going to write as u to the minus 3. Okay, but now this is really easy to integrate. We just have power rule mostly. So this is going to become u to the 4th over 4 plus 3 halves u squared plus 3 natural log absolute value of u, and then this last one's going to become minus, let's say, 1 over u squared. Now to finish it off, I'm just going to back substitute with my u value. So let's see, for our solution, we're going to have just tan to the 4th x over 4 plus 3 halves. This is going to become tan squared x plus 3 natural log absolute value, and then we're going to have just a tan x. Oh, sorry, I should actually have a 1/2 in front here, or a 2 in the denominator. And again, because we have 1 over u and u is tangent, that's going to be the same thing as the reciprocal or cotangent. So I'm going to write this as minus 1/2 cotangent squared of x plus c. Circle it, and we're done. Okay, good problem. We'll stop it there. Thanks everyone for watching today. Please like and subscribe. Have a great day.